So my answer choice is E. All right, three more. 26, let G be the function with first derivative given by G prime equals yada yada yada. Which of the following must be true in the interval from 0 to 2? Ooh, all right, let me write that one down. So we have okay, G prime is the interval from 0 to x, integral, excuse me, from 0 to x of e to the negative t squared, is that right? E to the negative t squared dt. And this is number 26. Okay, got it. And we're looking at the interval from 0 to 2. All right, let's take it one at a time. Which of the following must be true? We're going to go down the list until we find one that's not. G is okay, they're asking me increasing and concave. You know what, let's do this. Increasing and decreasing come from first derivative. So since we're at first derivative, let's talk increasing and decreasing. If we set this equal to 0, this graph, I don't know if y'all are familiar with it, but the only place that this would actually be equal to 0 is at 0. If you plug in 0 for x, you haven't gone anywhere, so you haven't gained any area, which means your derivative would be 0. This function, it never dips down into the negatives. The e function is never negative, and no exponential is unless you flip it. So this will always be positive, which for me means that G will always be increasing. That makes sense. This never dips into the negatives, so this answer, whatever this is, will always be some positive number, which means G prime will always be positive, so G is always increasing. Can I narrow it down? I can narrow it down to A and B. Is that right? Okay. Okay. Then we need to look at concavity. G prime. I'm sorry, G prime prime, G double prime. Well, the derivative of the antiderivative is simply going to be the function inside, so this is going to be e to the negative t squared. Again, I can't set that equal to 0 to get it to be anything else. It won't ever equal 0. So I'm getting that this is always positive, just like this is always positive. So I'm going to say G is always concave up. So my answer would be increasing and concave up, which is A. Did you do it this way? That's a tricky one. By this point in the game, this is what, at this point in the testing, your brains will probably be mush by now, and y'all will be about ready to, just.
Stay right. But multiple choice, I was like, you know what, let me just, I looked around to see which ones were the quickest ones.
And we are spending a good deal of time on this. You only had 55 minutes, so there will be some of them that you would honestly just say, you know what, move along. And this might have been the ones that y'all were like, you know what, let's just move along.
I did pretty good guess.
27. Oh yeah,
Those are the
put
ones
something
that I
down.
could
Make it a good
get.
guess. 27.
I did skip one on accident.
I'm sorry. Okay, we have x plus 2y dy dx is equal to 2x minus y. They want you to find the second derivative at 3, 0. The very first thing I would have done was solve for dy dx and and gotten 2x minus y over x plus 2y. Make it easier. All right, second derivative, here we go. d2y over dx squared, low, d high, this is just straight up implicit, less high d low, which is going to be 1 plus 2 dy dx, all over the bottom squared. And they wanted me to do the 0.30. Well, the nice thing about this is all the zeros are going to, or the y's get knocked out. Here's what you got to keep in mind. I am doing it.
I solved for d minus dx before I did that.
You did that? That's exactly what I would have done, yeah. If you plug in 3, we're going to need 30 in this, so if we were to stick in a 30 here, the y's get knocked out, and this is 2. Okay, so we're going to need that. All right, so here we go. 3 plus 0 times 2 minus 2, because we found that 2, minus 6 minus 0 times 1 plus 4, all over, that's gone, thanks, all over, what am I plugging in, 3? 3 plus 0, 3, 9, okay, so we get, is that 6 times 5, which is 30, over 9, divided by 3, 10 over 3.
-10.
Is it negative? What that was, oh, you're right,
Negative.
negative, good for you, thank you, I'd have gotten that one wrong. So, A. Good eye. Last but not least, and then we will call it, because I think y'all are just burnt out. Y'all got, whatever it is you need to do to build up your endurance by third block, because from here on out, we're gonna be in full tilt practice mode, come into ready to work.
I'll make coffee.
No more computers, no phones, no fun. For t greater than or equal to 0, the position of a particle moving along the x-axis is given by. All right, so we are given a position. Let's see. Position, here we go. X of t is equal to the sine of t minus the cosine of t. What is the acceleration of the particle at the point where the velocity is first equal to 0? All right, acceleration is second derivative, but we need to make a pit stop by first derivative to figure out where his very first stopping point is. So, first derivative. Derivative of sine is cosine.
Oh, that's what I messed up.
Derivative of negative cosine is positive sine. So the question is, where does that first equal 0? What was my time? Greater than 0?
Well,
Okay, here's what I'm thinking
it
about.
has to be in the second quadrant.
Right, it is
Yes.
3 pi over 4,
Yeah.
the 45 degrees,
Yeah.
right?
Be the 2 pi over 2 minus, negative 2 pi over 2, 2 pi over 2.
Root 2 over 2.
Root
yeah,
2
right.
over 2.
So, a couple ways to do it. If you do this, you end up with something like the cosine of t equals the negative sine of t. So you should be thinking to yourself, where do the sine and the cosine equal each other? And that's at your fourths, your pi fourths, kinda.
3 by 4.
Yeah, 1 and 3 and 5 and 7. And the one where they have opposite signs, the one in the first quadrant, they're both positive, one in the second quadrant, however. So t is equal to 3 pi over 4 is the magic number. So now what we're going to do is jump to the second derivative and then plug in 3 pi over 4 and we're done. Second derivative, a of t. Derivative of cosine is negative sine. Derivative of sine is cosine, so we end up with the exact opposite of what we started with. And we're going to do a of 3 pi over 4. All right, Sign of that is positive root of 2 over 2, because this makes it negative, so we're gonna have negative root of 2 over 2.
And cosine is already negative.
Cosine is negative, so negative root of 2 over 2. Those two don't cancel each other out. You end up with negative 2 roots of 2 over 2, or negative root of 2, which is a. Boom. Alright, how long did we spend going over that? When did we get in here? Let's say we started about 20.
I'm positive.
Here, I'm moving to
Say about 20. All right, going over it together on the board, it took us a little over an hour, hour 10-ish. On the test, you had 55 minutes. They do not expect you to be masters of this stuff. They don't expect you to get them all right. They're, statistically speaking, it's somewhere between 1% and 2% that get every single question right on the AP test. All right, so out of the, how many thousands of kids they have take this, 50,000, 60,000, something like that.
50.
About 1.5-ish, 2% is usually about the acers. These are the kids that don't get anything wrong.
They're genius.
About,
Like 50 of them.
it's,
I think it's 11% percentage.
do I?
Is it really like 1%?
It's about 1.5 to 2%. They give us these stats every year, and I
So it's
think
like 50 people, if there's 5,000 people too.
50,000 people that take it, so about 500 kids a year.
Ace it.
500 to 1,000, say about 1,000 kids.
Ace it.
Yeah.
Holy crap.
Yeah. Now that is covering all of the United States and all of the United States affiliates, like military bases
Yeah.
and DoD things, all that other stuff.
Oh,
How many multiple choice should we be shooting for? What's the magic number?
all.
20. Okay? 20 is the 3 line. For this particular year, 20 was the 3 line.
I got 19.
Now, you made up for it in the free response. If you are getting 20 multiple choice right and 4 points on each free response, that's a 3. That's what we're shooting for. Now, we want more than that, obviously, but think attainable goals, and then we raise those goals. All right, we're gonna pause here. We'll go ahead, we'll pick up the calculator part tomorrow and start on free response. I doubt we'll get through all of it, but we'll start on it, because we got a lot to talk about with free response. Those scores were abysmal. I mean, hideous. Some of the things I was like, okay, they should have at least scraped by with 1 point on this. Some of y'all weren't getting anything, so we're really gonna talk about free response. All right. So, all right, I need the folders back, because the